Hey there. Let's start our first topic in D3, that is D3.1 variable costs and fixed overhead allocation using cost drivers. Sir, I'll keep it very simple. You already know all this. We have already covered all this in the previous D1 and D2 topics. So I'm just going to go through this so that you will just recap those topics. Nothing new to explain, literally nothing new to explain. Just recap of what we already learned in D1 and D2. So we have a lot of indirect cost. So what are indirect costs? Indirect material, indirect labor, and all other indirect expenses. These are allocated to cost pools or cost objects using the cost drivers that are considered to have a strong relationship to incurrence of these costs. The cost drivers that are used to allocate indirect costs are referred to as the allocation basis. So if you remember, rent is allocated on the basis of space occupied. So space occupied, rent is called as the cost pool, and space occupied is called as the cost driver, right? That's all. So here space occupied cost driver is called as allocation base. So a cost driver which is used to allocate the indirect cost is referred to as an allocation base, this one. Now accounting for overheads. How are overheads accounted? But when traditional costing is used, all indirect costs are allocated to a single cost pool called as an overhead. Overheads may be accounted using the ABC also. Sir, in case of traditional costing, traditional means absorption. What we'll do? Labor hours, machine hours, or number of units. Only one single rate will be there. Single rate will be there. Whereas if you use ABC, then you will have various cost pools. Each cost pool will have different cost drivers. Each cost driver will have a allocation rate, and then allocation to the products will be done based on that allocation rate. You remember all this. Now when traditional costing is used, application is accomplished in two steps. How do we do it in absorption costing? So first we calculate the predetermined overhead rate, estimated budgeted overheads divided by estimated cost driver. Usually the cost driver will be labor hours or machine hours or number of units. I'm repeating multiple times so that it will be there in your memory forever and ever. So step 1 is always done at the beginning of the period with budgeted or estimated number. And how do we apply them? As and when the number of units are increased, or number of labor hours or number of machine hours are spent, hours spent into or units produced into the predetermined rate. Actual cost driver into overhead rate from step 1. That's how we do it in traditional costing, right? So now coming to variable overheads. So variable overhead expense allocation. So what are different examples of variable overheads? You can see direct labor hours, the allocation basis for variable overheads based on labor hours, based on testing hours, based on engineering hours. Direct labor dollars, if you are directly paying the labor in dollar amount instead of hourly rate like fixed. Machine hours, number of units produced, all of these are different variable overhead related drivers. So you can see this question. Alpha Corporation is analyzing its variable overhead expenses to determine the most accurate method of assigning variable overheads to each of the product. Like how do they allocate the variable overheads to each of the product? Alpha has identified the following variable overhead expenses. They have utilities expenses, they have repairs expenses, they have inspection expenses. So let's say inspection is there. If they have two products, product A and product B, how do they allocate the inspection charges to product A and product B? Based on number of units produced, right? Repairs based on the machine hours, utilities based on machine hours, like that. See, identify a potential cost driver for each of the above expense. For utilities, number of machine hours. If the machine hours are running longer, if you take more machine hours for a product, then utilities will be more required. Utilities means electricity, heating, cooling, water, all that stuff. Repairs. So if the number of machine hours are increasing, chances of repairs also will be higher. Number of machine hours, more hours running the machine means more repairs and more maintenance is required. Inspection. You inspect the units that are produced. So number of units produced. The more units are produced, the more inspection is needed. So how do we calculate the variable overhead cost per unit? Total variable overhead cost divided by number of units produced. This is common sense, nothing new here. I don't think there is anything I need to explain to you in this topic. Talking about next, fixed overheads. Fixed overheads are often allocated on the basis of the activity which is most related to the capacity. Example of allocation basis, denominators ma. Denominator for fixed overhead allocation. Budgeted usage of machine hours or labor hours, budgeted level of units produced, physical capacity, total units that may be produced, floor space for building depreciation and property taxes or rent, etc. You can use floor space. These are all denominators. Denominators, okay? Allocation basis basically. So see this question, Alpha Corporation is assigning fixed overheads to each of its product. Alpha has identified the following fixed overhead expenses. They have factory rent, depreciation and supervisor salary. So factory rent will be allocated on the basis of square feet or space. Depreciation can be allocated on the basis of machine hours. Supervisor salary, usually supervisors are paid per hourly basis, so labor hours. Right? You can see the solution. Factory rent is allocated on the basis of square footage. Depreciation is allocated square feet of factory. Oh, okay. In case if you don't know the machine hours, then you can go for square footage, but else usually we can use machine hours for depreciation. If it is machinery, if it is another vehicles or something like that, then different allocation base can be there. Supervisor salary, direct labor hours. Sir, all of this we already know, nothing new. So I again gave you some links here so that if you want to go over absorption, under absorption and all, that is covered in D2.3.7. If you want to refer ABC, that is covered in D2.3. So these two are already covered, so you can refer to that. Next, I'm covering all the basic topics here in this one video. I don't want to do breaking 3 different videos for this silly topics. So next one is regression for estimating the total fixed cost. Sir, we know this equation. Even though you don't know the equation, I'll tell you how this equation works. So total cost can be calculated as fixed cost plus variable cost. What is there in that? Fixed cost plus variable cost. Okay, this we know, sir. Now, can I consider fixed cost, because fixed costs are calculated in total, plus can I break this variable cost into variable cost per unit into number of units? Sir, how do you get total variable overheads? Variable cost per unit into number of units, right? So that is this formula, y is equal to a plus bx. Y is the total cost, a is the fixed cost, b is the variable cost per unit, x is the number of units. So total cost is equal to fixed cost plus variable cost per unit into number of units. This formula. Total cost is equal to fixed cost plus variable cost per unit into number of units. Y is equal to a plus b into x. Okay, see here. A is called the fixed cost, B is called as the variable cost per unit, X is the activity level, number of units produced. So you can see a small example that I have given. So fixed cost is 8,000. So total cost is equal to fixed cost plus variable cost per unit into number of units into liquid. So TC is, or else if I use the terminology, y is equal to a plus b into x. So total cost y is equal to fixed cost is 8,000 plus variable cost per unit is given as $3. 3 into 2,000 units are produced. So 3 into 2,000 is 6,000. 8,000 plus 6,000. 14,000. So total cost is equal to 14,000, right? Okay. There's also one small question given for you. Units produced 100, 200, 300, 400, 500. Total cost 3,000, 4,500, 6,000, 7,500 and 9,000. So using this, estimate predict the total cost if you produce 600 units. So if you produce 600, what will be the total cost that you have to produce? Sir, simple. Use high-low method that we already discussed in D1 last point. So if you remember, if not, good for you. So how do I calculate variable cost per unit is equal to highest cost minus lowest cost divided by highest volume minus lowest volume. So highest cost is 9,000 minus lowest cost is 3,000. Highest volume is 500 units, lowest volume is 100 units. So 9,000 minus 3,000 is 6,000 divided by 500 minus 100 is 400. So $15 per unit is the variable cost. So substitute that in the first any one of these levels, lowest level or highest level. So if I take 100, so 100 into $15, this is the variable cost, plus fixed cost is equal to total cost is $3,000. So that implies fixed cost is equal to 3,000 minus 1500. So my equation will be total cost is equal to fixed cost plus VCPU, variable cost per unit, into number of units. So if I substitute, fixed cost is 1500 plus variable cost per unit is 15 into X. So my equation is basically y is equal to A plus BX, y is equal to A plus BX. Y is equal to A is 1500 plus B is 15 into X. This is my equation. Y is 1500 plus 15x. You can see here total cost is equal to 1500 plus 15x. Sir, you can either use high-low method or you can use some Excel spreadsheets and all to find out this equation. Not possible in exam, so use high-low method. That's why I told you, even though high-low is technically removed from the syllabus, still it is needed for this topic. That is why I taught you in D1. I told you also, even though high-low is removed from the syllabus, you should still learn it, because without that you will not be able to do the regression. Okay, chalo. So for 600 units, y is equal to 1500 plus 15 into 600 units. They asked us to calculate for 600 units, na? 600 units. So that would be 1500 into 600, that is 6,000 plus 3,000, 9,000 plus 1500, 10,500. Total cost for 600 units is 10,500. Predicted as 10,500, right? Chalo. So with that, we wind up the first recap topics of D1 and D2, fixed cost and variable cost. So in the next lecture, we are going to start with D3.2, I guess, overhead allocations. Yes. Okay, overhead allocation methods will start in the next lecture. So you guys take care, keep smiling, take care, bye bye.